Today we are going to compute certain pieces of information necessary for a host to be part of a network. Given the IP address and prefix length of a host, these are the two pieces of information necessary to configure a host into a network. From these two pieces of information, we can compute the subnet mask, network address, and broadcast address of the machine. The subnet mask is simply an alternative representation of the prefix length. The network address is basically a number that can identify whether two hosts are part of the same network. And the broadcast address is used to identify the IP address used whenever machines within the same network want to send messages to each other. First, we're going to use the IP address 192.168.0.1 and with a prefix length of 24. So first, we compute the subnet masks. So first off, 24 simply represents the number of ones in a prefix length in a binary representation. So in this case, we will have 24 ones. So first set will have 8, followed by another 8, and finally another 8. Then followed by zeros because we now have 24 ones. If we convert this binary dotted notation to dotted decimal notation, we would get 255.255.255.0. And that is the subnet mask. Next, we compute for the network address. Network address can be computed by roughly the formula IP address and subnet mask. In this case, the IP address is 192.168.0.1, then logical AND the subnet mask, which is 255.255.255.0. Then we apply the logical AND to each and every number. So 192 and 255 is 192, 168 and 255 is 168, 0 and 255 is 0, 1 and 0 is 0. And this gives you the subnet mask. After that, we compute the broadcast address. The broadcast address can roughly be computed by the formula network address or logical OR not of the subnet mask. So first off, in this case, our network address is 192.168.0.0, logical AND not the subnet mask. So the inverse of the subnet mask, 255, flip all the ones to zeros and zeros to ones, we get 0. Not 255 is 0, not 255 again is 0, and not 0 is 255. Then we apply the logical OR on every number. 192 OR 0 is 192, 168 OR 0 is 168, 0 or 0 is 0, and 255 or 0 is 255. Now we have the broadcast address of this IP address. Let us take another example. Here we have the IP address 192.168.100.1/25. Of course, now we can copy the previous example where we have 8 ones first, followed by our 8 ones. We get 16, another 8 ones, 24, and one more 1. Then it's followed by zeros. So we have 7 zeros left. Okay. Then we convert them into decimal notation. So all ones is 255, all 8 ones is another 255, all 8 ones is another 255, and 1 followed by zeros is 128. Then we compute the network address. In this case, the IP address is 192.168.100.1. Then we do a logical AND with the subnet mask, which is 255.255.255.128. And then we compute logical AND for each and every number. 192 and 255 is 192, 168 and 255 is 168, 100 and 255 is 100. 1 and 128 is 0. Then we compute for the broadcast address. So this is basically the network address, or not the subnet mask, not 255 is 0, not 255 is 0, not 255 is 0, not 128 is 127. Then we apply the OR on every digit. 192 or 0 is 192, 168 or 0 is 168, 100 or 0 is 100, and 0 or 127 is 127. And this gives us our broadcast address. Now let's take a last example. Say I pick a number 192.168.100.129/25. Is this the same? Is this in the same network as the address above? Well, we can find out by computing its network address. First up, we compute the subnet mask again, which is the same as the one above. So we write our 25 ones, followed by 7 zeros. And we get the same subnet mask 255.255.255.128. Then we compute the network address. In this case, the IP address is 192.168.100.129, and subnet mask which is 255.255.255.128. So what do we get? 192 or 255 is 192, 168 or 255 is 168, 100 or 255 is 100, and 129.128 is 128. So since we don't have the same network address, then that means 192.168.100.129/25 is not in the same network as 192.168.100/1. That is all for today.